All right, so last time we were talking about how to appropriately round in science and how to account for measurements. So a lot of people use these two terms interchangeably, accuracy and precision, and they do not mean the same thing. Accuracy is basically how correct you are. Precision is how close a set of measurements are to each other. So basically, let's see if I have this picture of Joffrey right here, and then I put an arrow, or not an arrow, but a target on him. Then I decide I want to throw darts at it. If I can hit the target, I'm accurate. So let's say that I hit here, I'm accurate. If I were to repeatedly shoot arrows at him and then I get the same spot, then I'm precise. So precision is how close you are when you do a series of measurements. Accuracy is how correct you are. So if I kill him, then I'm accurate. If I'm precise, then I kill him in the same spot over and over again. You can have one without the other. It's unusual, but you can have that. So let's say that I throw my darts and maybe I throw them over here. So I hit one here, I hit one here, I hit one here. So all of my darts are relatively close together, but I did not kill him, so that would be inaccurate. And I am precise though, because I kept hitting the same spot over and over again. So this would be like if you were to go and take a measurement and you put it on the scale to weigh it and you got 5.0, and then you got 5.0 again, and then you got 5.0 again. Well, it turns out the scale was not calibrated and the number should have actually been 7. So you were precise, you kept getting the same measurement over and over again, but it was consistently incorrect. Now, you could also have a situation where you are accurate but not precise. So let's say that I hit an arrow right here, then I hit another arrow right here, but then I get one right here. Well, I was accurate because I eventually hit him, but I was not precise about it. So it was almost like I kind of got lucky. So you can have accuracy without precision and vice versa. It is unusual though. Usually if you are accurate, you are usually consistent about it. But it really depends on your instruments and your method itself. All right, so when we're looking at accuracy and precision, you need to be able to look at data and tell, is it accurate, is it precise? So 3 groups were taking length, and the length should have been 6.000. Well, okay, set A got about 5.8-ish, set B got about 6.0-ish, and then set C was about 5.8 again. So of these sets of data, which one is the most accurate? So which one is the most correct? Well, that would be set B, because this one is the closest to 6. So it is the closest to being correct. Now, which set is the most precise? Well, this one is a little bit harder to tell. What you have to do is you have to look at it. Okay, so all of these numbers go out to the 3rd decimal place. Okay, and in order to be precise in this case, it's a little bit harder to tell because we've got all these numbers, and a lot of them, it looks like they're precise, but you really need to look at it. Okay, the last number might fluctuate a little bit, and that's okay, because remember, the last number is the one that's actually estimated. The other numbers should all stay the same. If it's precise, everything else should be the same. So looking at this set of data right here, I've got 5.86, 5.87, 5.87. And then all of these numbers, of course, are different. If I look at this set right here, this is the only number that has changed. Everything else is consistently 6.00. So let's compare this one. Okay, so remember, this is the number that can fluctuate. But again, we got a 7 here, we got a 6 here, and then we got a 7 here. So technically the most precise set of data would actually still be B. So accuracy is how close you are to being correct. Precise or precision is going to be where the numbers are very, very close together. But if you have a large decimal point like this, you want to look at the last decimal, and everything else should be the same if it's precise. Okay, so you are going to be taking percentage of error a lot in this class, and basically it just tells you how correct you are. So if you have a very low percentage, you are a rock star chemistry student. Okay, so if your percentage of error is low, it's good. And in order to get that, you're going to take the real value, which is basically the correct value, whatever you should have gotten, and you're going to subtract what you got in the lab. So this is your measurement, and then divide that by the real value, so again, the correct, whatever it should have been. And then, of course, take the absolute value. These are absolute value signs. You should never have a negative percentage of error. And then, of course, multiply it by 100 at the end. Okay, so let's say that you should have gotten a length of 5, okay, but you got a length of 4. All right, so 5 is what you should have gotten. 4 is what you got. Oops. All right, so you should have gotten 5. You got 4, though. So just plug it into the formula. All right, so 5 minus 4, and this should be a 5, sorry. 5 minus 4 should be 1 out of 5 times 100 should be about 20%. So you have 20% error. So you definitely did something wrong. Maybe you need to look at your method. Maybe you need to look at what you did. But there is definitely some error in that measurement. All right. So next time we're going to be talking about atomic structure.